Alrighty, so join us on a little fault find of an EV point that we had recently. Customer saying they're plugging in and it's not charging. So we head to site. First things first, we need to check the condition of the plug itself. As you can see, water builds up in this cap, so if you can, leave the caps off so that you don't get corrosion in your plug. Next, we have a little go at plugging it into the car, see what happens. So you see it goes and flashes, and the car initially calls for the charge to begin, at which point it immediately rejects the charge and goes into a fault. Now, I've already got my suspicions what this fault would be. It's a fault that I've come across before with Renault Zoes, and it's commonplace on a lot of electric vehicles. So I can confirm it by showing that the EV point is clicking into and out of charge using my EV tester. And so it's calling for charge, and the EV point is clicking into position and allowing the voltage and electricity to flow. So what the problem could be, Renault Zoes have a what's called earth fault loop impedance maximum resistance of 150 ohms. That's really quite high, so it will be on a TT. What we mean by TT is you've got an earth rod in your garden somewhere. However, this house hasn't got an earth rod, it's what's called a TNCS, so the neutral is the earth. And so a reading like that is ridiculously high and very unsafe. The system that they've installed is not the neatest and hasn't got all the safety systems, but we'll come back to that. So firstly, I'm going to test between live and earth there, as you can see, just to double check my readings. You can see I'm still getting a really high reading, 366, way above the 150 limit. So the Renault Zoe is going to reject the option of charging. So to put those readings into perspective, what we'd normally expect on a TNCS system is a reading of 0.17, maybe 0.2. We're getting 45 ohms. So that wasn't the reading I was getting a minute ago. So it's obviously changed. Me putting pressure on there has changed the reading. So I've got to check between live and neutral. That should be exactly the same because the neutral and earth are shared on these types of earthing arrangements. So I'll run a quick test and see what we got. So we've got 0.42. It's high for a TNCS, but it's not ridiculous. So we've confirmed that there's a problem with the earth there. Now, as you can see, I've taken the fuse cover off there, and that's what's called the meter head and the fuse head. And you can have a look in there, and you can see they're all actually connected with metal in between. So there should really be no reason. However, as you can see, when I'm putting my probes between the live and the earth, we're getting arcing because the resistance is so high. So you can see where I've taken the screw out that goes between the earth and the neutral plates there is some serious discoloration and signs of heat and arcing that have gone on between that screw and the contact point. So I've checked between the bottom part of the earth and the live, and I'm still getting really high resistance and arcing when I'm putting my probes on there. So really bizarre, because they are literally in contact with a piece of metal there, so I can't see a reason why they would have poor contact overall. Anyway, that's not for me to sort out, that's for the electricity supplier to sort out. I'm just here to identify and diagnose the fault. So with faults like this involving the main fuse and supply head, it is the responsibility of your electricity supplier to come out and fix it. So I made a note and got in touch with them, and they're coming out shortly. With that in mind, turn my attention to this little beauty, which is a undersized cable coming straight out of the mains there. So that cable coming straight out of there is undersized for the potential current it can carry in a fault. So we'll have to address that when we come back. The fault we identified while we're here was the incorrect RCD has been used, potentially leaving the client open to an electric shock if there was a DC fault. So again, we need to address that when we come back. And finally, for any electricians listening, there was no pen fault protection. So no earth rod, no pen fault protection, leaving the client wide open to a pen fault and again, potential electric shock. If you've got any electrical problems or problem with your EV or want an EV installed, give us a call.